Hi, today's class is about atom. We have lot of doubts about atom. How atom will be there and how its structure will be there, what is inside the atom. So, in today's class we are going to know about atom. We are going to know about what are the fundamental particles present inside the atom and how atomic spectra will look like. This is the atom. This concept is brought by a scientist called Dalton. He said that matter is made up of indivisible particles, so called atoms. These atoms can neither be created nor be destroyed. So he said that generally in chemical reactions we do, the atoms will the amount of atoms we kept in the reaction is equal to the same amount of atoms we get at the output also. So according to him, the atoms can neither be created nor be destroyed. But his student, one of the scientists, J.J. Thomson, later on he proposed a theory that atoms can be further divided into subparticles, that is protons and electrons. He is the one who brought the electron concept, and he said that atom is spherical in shape and the positive charge is all over the atom and the negative charge is embedded in the positive charge. He said that negative charge is embedded in the positive charge. The white part is positive charge which is present all over the atom. This is the negative charge. Just it looks like, if we take an example of a watermelon, the red pulp which is present, that is called as positive charge, that is proton, and the seeds which are embedded in the red pulp, that are called as negative charge, which are called as electrons according to him. And this is called as plum pudding theory. According to him, the atom is neutral. The atom is neutral because he stated that the number of electrons is equal to the number of protons. So later on we came to know that this theory has also some of the drawbacks. And another scientist named Rutherford, he also said one more theory, Rutherford's atomic model. Rutherford is the scientist. He has conducted an experiment. That is, he has taken a polonium source. He has taken a polonium source which emits the alpha rays, and it is passed through a slit so that the rays will not be deflected, and it is then passed through and it is made to fall on a gold foil. And then they are deflected. This is the zinc sulfate detector. Here the polonium source is taken. Polonium is a radioactive metal. It emits alpha particles and it is allowed to pass through a slit. So and then it is allowed to pass on a gold foil, thin gold foil. And the rays from the gold foil, they are passed through and they hit the zinc sulfate detector. How we can know these are the alpha particles? Because zinc sulfate is the detector of alpha particles. So when alpha particles hit the zinc sulfate, they create some fluorescence. So we can know that is the alpha particle. In this experiment, he had made 3 observations. The first one is all the rays cannot easily pass through the gold foil. Some of them are getting deflected. Some of the rays are getting deflected. And in the second observation, he found that maximum of the rays, they can easily pass through the atom, gold foil. And in the third observation, he found that some of the rays are retracted back to their path. Some of the rays, they are retracted back to their path. By making these three observations, he made a conclusion that positive energy is not present all over the atom. So, if positive energy is present all over the atom means, then every ray will be reflected back. So, he stated that positive energy is not present everywhere in the atom. It is present at the center of the atom, which is called as nucleus. This positive charge is called as nucleus.